Good evening. So we are having here Smith Parmar, who is will be I'll be taking his mock interview. Is currently will be giving his Anglo interview. So let's move on. So Smith, go and introduce yourself.
Good evening, sir. My name is Smith Harshad Parmar. I am 23 years old and I currently live in Mumbai, Maharashtra. I do not have any siblings. My mother is a school teacher and my father works in programming department in theater industry. Coming on to my hobbies, I have four hobbies. I like to train my mind and mind and my body at the gym. Secondly, I like to teach. I undertook few students in my third year of BTech Mechanical Engineering. This them in their SSC exam. Thirdly, I like to learn about cybersecurity, and it is kind of a hobby that I developed in the second year. And lastly, I enjoy woodworking. Coming to my academics, I finished my diploma from KJ Somaya Polytechnic with 673.9%, and I finished my BTech in Mechanical Engineering from Sri LR Tiwari College of Engineering, which is a Mumbai affiliated college with 70 percentages. Next, my skills and my advantages are the four skills that I have developed via my hobbies throughout the years. Firstly, while training in the gym for years and years, I have developed that continuous hard work and discipline beats talent. My second skill that I developed was thorough communication and presentation of a way where you can understand through different crowds. While teaching, I understood people who are not at my intellectual and communication level, and then I communicated them to understand the subjects. Thirdly, I learned that success through perseverance. Even though I am a solely core mechanical student, I learned that even reading a page a day and understanding a single letter every day will give me success, from which I have achieved an internship in a multinational company in cybersecurity in my second year of engineering. Last but not least, my main focus and my main skills are responsibility, decision making, and developing for developing connections on a professional level, which is I have learned from my current company, Felder Group India, which is a MNC in woodworking and manufacturing machines.
So okay. So okay.
Hello.
Okay. So it was a good introduction. So let's move on. Um, State the Pascal's law.
Pascal's law is a law when in a confined space, incompressible fluid is pressurized, the pressure is transmitted in every direction. Pascal's law is used in everyday objects like lifting a heavy car jack or a hydraulic
It's good,
presses.
good. Only Pascal's law. It
Okay.
is transmitted equally in all direction. Okay.
In all
So
directions.
yeah, 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 it's good. Be concise to the question. Okay. If it says examples, then only say examples. Okay. If it just said to be stated the Pascal law, just state. Okay. Um, list out the boiler mountings and the functions.
The boiler mountings are as follows. There are safety valves, gauge glasses, low water level shutdown, low water level shutdown. There is a feed check valve. There is pressure gauges. There is boiler blowdown valve, scum blowdown valve, air vent cock, steam stop valve, and fusible plug. Functions are as follows. There are two safety valves present on top of the boiler with a difference of zero point 0.5 bar. These safety valves are present to ensure that the boiler pressure does not go over the limit that is predetermined before. The gauge glass is there to determine the level of the water that is present inside the boiler, which is at the side of the boiler. There are usually two gauge glasses present. The pressure gauge is a gauge which determines the pressure of the steam developed inside the boiler. This pressure gauge cannot be of any low quality. It has to be a really high quality, good pressure gauge. The fit check valve is there to ensure that appropriate amount of water is getting inside the boiler, whereas the steam is not getting inside the pump, which is pumping out water. Air vent cock is there to
Just
present
mention NRV over there. The feed check valve is a non-return
is
valve.
is a non-return valve.
Yeah,
Okay.
let's maintain.
Okay. The air vent cock is there to present to open up the boiler when while cleaning or stuff, so that if the boiler is shut down and the steam condenses down, so it does not implode. And the second function of air vent cock is to, while clearing out the air from the boiler, they fill up the boiler and the water overflows. That ensures that there is no air present inside the boiler. The scum blowdown wall is present at the top layer of the water surface, where scum which is developed on the surface of the water is thrown out, and the boiler blowdown wall is present at the bottom of the water surface, which is there to remove any hard sludge, mud, or any hard material that are present at the bottom of the boiler. Uh, what is next? Fusible plug. Fusible plug is a tapered threaded device which is present inside the water of the which is present inside the water. When the water level drops below this fusible plug, there is a material of low melting point
It
present
is present,
inside, which is
beta. It is present inside the.
it is present inside the top cylinder of boiler
You should mention steam drum. In case of a water
or
tube
steam
boiler,
drum.
yeah, it is present
Okay,
at the
okay.
bottom of the steam drum. Okay, so just mention this.
The fusible plug is present at the bottom of the steam drum of the boiler. It is a threaded device usually made up of brass, bronze, or gun metal, which has a filling of a tapered shape of material which has low melting point. So when water level drops below the fusible plug, the melting point, due to the high temperature of steam, the metal melts and the water flows down and it shuts down the boiler. What? Uh, yeah. And steam stop valve. Steam stop valve is present to stop the flowing of steam through the boiler to the different parts.
You can mention it is used to stop and also regulate the flow to the out. It's like from the outlet to regulate the flow of steam, also to
Yeah.
shut or the open the steam. Yeah. So, what happens when air is present inside a centrifugal pump?
When air is present inside a centrifugal fan, there are two possible phenomena. First, we all know that air is compressible, whereas water is not. Let's take an example that our centrifugal pump is pumping out water. So, when uh, when the motor is turned on and the negative and the impellers are turning, the air, instead of getting thrown out radially, the air compresses down, and it is not able to create enough suction pressure from the centrifugal pump, which means the efficiency will be reduced of the centrifugal pump. Secondly, the density of air is 1000 times less than the density of water. That means by the formula of centrifugal force, that is mr omega square, we get to know that the centrifugal force delivered when water is present is going to be 1000 times less than the centrifugal force delivered when the centrifugal pump is completely filled with water. Hence, uh, air should not be present inside the centrifugal pump.
Okay. Differentiate between centrifugal pump and a positive displacement pump.
Okay. Centrifugal pump is a pump which works on a rotodynamic principle, whereas positive displacement pump works on the principle of positive displacement. Centrifugal pump uses impellers and the expanding volume of volute casing to displace the fluid and revert it toward discharge. Whereas the positive displacement pump uses gears, screws, and vanes to deliver the output. There is no requirement of relief valve in centrifugal pump, whereas there is a definite require of relief valve in positive displacement pump, because when pressurized, the discharge of centrifugal pump gets lower, and the pressure does not matter to the positive displacement pump. Even with high pressure at the discharge side, the positive displacement pump keeps on pumping out the fluid or the liquid. Centrifugal pump is used where we have to displace only, where we have to pump out only water, and positive displacement pumps are used in all kinds of fluid, whether it be mud, oil, sludge, or any other thick viscous fluid that is not able to pump out the centrifugal pump.
Okay. So how many points did you say? Five.
Uh, I haven't counted.
So okay. So how is cooling produced in a VCRS system?
Sorry.
How is cooling produced in a VCRS system?
Uh, this system works on refrigerant's latent heat of cooling of changing its phase. So every refrigerant has its latent heat of absorption. So after the thermostatic expansion valve, when the refrigerant is passing through the evaporator, it is a mixture of vapor, a little bit of vapor, and 80% of it is around liquid. So this liquid has its latent heat of absorption, and it absorbs the heat from the refrigerated area, and it turns into a vapor. This absorption heat is also helped by the fact that there is a evaporator fan which flows the air throughout the whole room. So this is how latent heat is produced inside a refrigerator. For example, let's take R134A. Its
This is
latent heat
fine.
of
This is fine. This is
uh,
fine. What is reflection and refraction?
reflection is a phenomena when a ray is bouncing on a reflective surface and it is reflected at an angle of incidence with a normal present on the same plane. Whereas refraction is the phenomena where the light ray changes its path from the straight direction to at an angle. The yes.
Name some refer safeties.
Refer safety. Refer safeties are as follows. There is low pressure cutting, low pressure cutout. There is relief valve present at the compressor bursting disk. There is
Relief
solenoid.
wall anti-condenser. Relief wall only condenser, not compressor.
It should. It is on compressor.
Sure.
Yes.
Because what I am having is
Because
on the
compressor
condenser.
compressor is the only stage where it is compressed. So it is the only part where the refrigerant needs to release. Right. Condenser is not compressing anything. So there is no requirement of a relief valve there.
Where it is present on which part of the compressor?
It is present on the output and the input. There is two flows where the input comes here and output is here. So the pipe is connected with the relief valve in between.
You saw this on Ashish is this?
Low
Yes.
pressure cutting, low pressure cutout. There is a master solenoid valve. There is relief valve at the compressor. There is low low oil pressure alarm and trip, and yeah, these are the safeties of a reefer system.
Okay. Uh, differentiate between the two-stroke and a four-stroke engine.
A two-stroke engine has two strokes for all of its four processes, that is power, exhaust, suction, and compression. Whereas four-stroke engine has a dedicated stroke for every process, that is power, exhaust, suction, and compression. A two-stroke engine has less moving part, hence it is less complicated, and a four-stroke engine has more moving part, which is more complicated. For two-stroke engine has higher body to weight, power to weight ratio, whereas four-stroke engine has lower power to weight ratio. Of course, a two-stroke engine has less fuel efficiency, whereas a four-stroke engine has more fuel efficiency. That is, mileage is less in two-stroke engine, mileage is more in four-stroke engine. Two-stroke engine in two-stroke engine crankshaft to camshaft rotation is ratio is 1:1, whereas four-stroke engine crankshaft to camshaft rotation is 2:1. Since the ratio is 1:1 in two-stroke engine, it is connected via a chain drive or a belt drive, whereas in four-stroke engine there is a timing gear present in between to reduce the ratio. In four-stroke engine, a two-stroke engine is usually a bidirectional engine, whereas a four-stroke engine is a unidirectional engine. Two-stroke is generally used as the main engine in on board the ship, whereas four-stroke is used only as the auxiliary engine on board the ship. There is no requirement of stuffing box on four-stroke engine, whereas stuffing box is absolutely required in two-stroke engine. Two-stroke engine uses two different quality of lubricating oil, whereas four-stroke engine uses only one lubricating oil at the crankcase.
So why only the main engine is two stroke? Why not four stroke?
There are few reasons. First, one of the more important reason is that two-stroke engine is bidirectional. That is, without a necessity of an extra engine, our ship can move in forward and backward direction. Second, the two-stroke engine has high power-to-weight ratio. That means with smaller space and smaller weight, it can produce and develop more power. These are the two most important reasons why two-stroke engine is used on board ship as main engine, and auxiliary engine is a four-stroke engine.
Okay. And why did you say the stuffing box is present in a two stroke engine?
Yeah. Uh, since a two-stroke main engine burns heavy fuel oil, which is highly acidic in nature, that means the lubrication that you are using the cylinder lining needs to be of a high base number, highly basic, which or high TBN, which is a total base number. These kind of lubricating oil are generally more expensive than the regular lubricating oil. And since we are going to use 10 to 12,000 of liters of fuel lubricating oil every day on board ship, the cost of expensive lubricating oil adds up day by day. So there is a stuffing box present between the cylinder space and the crankcase, and the crankcase uses the normal lubricating oil, whereas the cylinder uses the lubricating oil with high TBN number. And stuffing box separates the both lubricants because the crankcase is a splash lubricant system.
Okay, so what is TBN?
TBN is total base number of a lubricating oil.
But what does it mean?
It determines the basic nature of a lubricating oil. The higher the TPN number is, the higher the basic lubricating oil is.
So it is the milligrams of KOH or calcium oxide present in 1 kg of fuel. So this is a definition of TBN. Okay, if it is asked, then this is the definition. Okay, and you mentioned about stuffing box before mentioning that two-stroke is used on as the main engine. Or first you said stuffing box and then the main engine as a marine engine. What did you say first? You
No,
said
I said marine engine, main engine first, and then the last point was stuffing box.
okay, okay, that's good.
Stuffing box, and then the last point was lubricating oil.
Okay, okay. First say the application of two stroke, four stroke, and then say that stuffing box, and then what else? Stuffing box and uh, stuffing box and this thing. That bi-directional thing and all. Okay. After
Okay, okay.
mentioning that, you can. Rest points are good. Why did you say fuel efficiency of a four-stroke engine is better than a two-stroke?
Since a four-stroke engine has a bigger diameter, or bigger and heavier flywheel, and there is a determined stroke for power. That means in one power stroke, the rotation of engine is power, exhaust, suction, and compression. That means four-stroke, which means the rotation of the RPM on engine is higher. That is why it is able to produce high power with less, high efficiency with less fuel.
Okay. And why did you say the two-stroke has a less moving parts compared to four-stroke?
uh, because because of the complexity of four-stroke engine, there is no different. There is gudgeon pin. There is moving crank pin, and okay, I have to prepare this.
So don't mention about moving parts, okay? Braganza had rejected one guy it seemed because of this. Okay. Explain me about the Faraday's laws.
Faraday's law of electromagnetic induction states that when a closed circuit is present inside a change of magnetic field, then electromotive induction is induced inside that closed circuit.
Electromotive force.
Electromotive force, yes, I said electromotive force is generated inside that closed circuit. The second Faraday's law states that the magnitude of the induced electromotive force is determined by the time rate change of the magnetic fields that the circuit is going through. its formula is minus d phi upon dt. The
What did
d
you
phi
say?
is
The
the
second law? Second law, what did you say? Say it again.
second law. I said the magnitude of induced electromotive force generated inside a circuit is directly proportional to the time rate change of the magnetic field that the circuit is going through,
Okay.
and its formula is minus d phi by dt. Whereas d5 is the electromotive force and dt is the time.
And
The
what is
minus
Lenz law?
the minus symbol in d5 by dt in the second law comes from Lenz law. Lenz law states that in while generating induced EMF in a circuit, the induced EMF produced is opposing the direction of the change in the magnetic field of the system. Hence the negative sign because of opposite direction.
Okay. Explain the auxiliary safeties.
The auxiliary safeties are as followed. There is overspeed trip. There is overspeed trip, low loop oil pressure, alarm trip, motor jacket high temperature alarm trip, crankcase release valve, and exhaust gas high temperature alarm.
How many
Rest
did you mention? Five?
five.
Okay. And at last, I'll ask you the Archimedes principle.
Okay. Archimedes principle works on buoyancy. Uh, when okay. when a body is partially or fully submerged inside a water body, then the fluid that is displaced is the weight of the fluid of the body. This law is derived from the law of buoyancy. That means when a body is submerged, there is force acting on all the surface of the body from all the directions. If this force of the water body is higher than the force of the weight of the body, then the body will float. If the force is lower, buoyant force is lower, then the body will drown.
So that's it for the day.